a quick recap on what we've been doing. We've dealt with logarithms. We know how to like find a logarithm of a number. We also know how to solve equations with logarithms in there, right? Now we're going to get to simplifying logarithms. We haven't really done much on taking a logarithm and expanding it into multiple simpler ones, or taking a really complicated addition, subtraction of logarithms and condensing it into like one logarithm itself. Okay, so what we're going to do is we're going to continue with the properties of logarithms. We did an example last class where we took this logarithm and we split it up into addition, and then we finally took the exponents, put them up front, and then our final answer was basically everything expanded out. Okay, if we don't remember what we did that day, how about this? Let's do another example. Okay, this one's not going to be in your notes. I don't think you can fit it in your notes if you wrote really big, so you might have to write this on a separate sheet of paper. Okay, but just to get our minds jogging on what we were doing before, let's do this extra example. Log base 7 of 4x cubed 4th root of y. So just kind of jog our memories on this one. Okay. So we have multiplication going on. We also have exponents kind of in the mix and a 4th root. What should I do first based on the last example that we did? So do we deal with the multiplication going on, or do we deal with the exponents first? The multiplication, right? The biggest thing going on here is the multiplication. If you were to do this in order of operations, you would think about the exponents first, and then like the multiplication is more general, right? So, Miriam, do you need the copy of this? We were just doing the next example. So, since we have multiplication going on the inside, this turns into addition on the outside, right? So log base 7 of 4 plus log base 7 of x cubed plus log base 7 of the 4th root of y. Any questions on what I did to get to the top row? What should I do next? What should be my next step? Bring the exponent. And first of all, that 3 there definitely needs to go on top, right? So we have a rule that says we're going to take this 3 and move it to the front, right? So this turns into log base 7 of 4 plus 3 log base 7 of x, okay? And then we have that last one, which is a little tricky. That's not an exponent, right? The 4th root of y. Is there a way we can turn the 4th root of y into an exponent? Good. The 4th root of y is the same thing as saying y to the 1/4 power, right? A square root is the same thing as the 1/2 power. 3rd root, 1/3 power. 4th root, 1/4 power. Okay, so anything else we can do to simplify this even further? Any exponents going on? Yeah, I see. You take the exponent and you bring it up to the front. So this turns into log base 7 of 4 plus 3 log base 7 of x plus 1/4 log base 7 of y. Oh, yeah.
So let's say like for the let's say it's not a 4, let's say it's like any other number. Would it still be like 1 and then whatever number it is?
Oh, okay. So I see. Like if this was 5, it would still be 5, right? But what if it was like 1, right? If it was 1, there would be no 1 there. You could do this, but if you type in log base 7 of 1 in your calculator, actually turns out being 0, right? So it doesn't matter if you split up that 1 or just not included at all, it's still going to cancel out. Next question there. Any other questions on this one? Okay. Before we're finished with this one, we do have to check something, okay? This guy here, log base 7 of 4. This could be simplified if it turns out into a whole number, right? If that was, for example, 3 or a half or -1, it might be a good idea to do this just for web assignment's sake, just for homework's sake. Okay, so log base 7 of 4. Isn't that the same thing as saying 7 to the what power equals 4, right? Is there any power of 7 that gives you 4, like clean? No, right? There's, if you type that in your calculator, it would be something really crazy, right? So what we're going to do here is just say that our answer is right here. Okay. Don't worry about the log 7. Any questions on this example? All right. So we did an example last class where we couldn't do anything, right? So it is very important to think about what we can do and what we can't do. If we have addition on the inside of the logarithm, we can't really do anything to simplify. Am I going to trip you up on a quiz or test? Probably not, but just a little example of something we can't do anything. Okay. So examples 3 and 4, I think you guys have the skills to do. So why don't we go through these 2, work in pairs or on your own, and we'll come back together in a little bit. Let's come back here. Cole did example 3. Do you kind of want to take us through each of your steps?
So start on base 3.
Mhm.
And then split that up into log base 3 of x plus log base 3 of c.
Mhm.
And that can be turned into log base 3 of x plus 1/3 log 3 of z.
Awesome, right? So this cube root turned into z to the 1/3, which got brought out to the front. Does anyone have any questions on example 3? Okay. So we did example 4. I didn't ask anyone to do this one because I didn't want anyone to write anything too much. Okay. So this one has an ln. It doesn't say log. What does ln stand for? Anyone remember? Log base e, good. So ln, you don't have to write this, but ln is the same as log base e. It follows all the same log rules. If you see ln, don't freak out, it's just another log. Okay. So here we have division, we also have exponents. What did you guys do first, the division or the exponents? The division, right? The division's like the big thing going on here, right? So we can change division into, I guess, subtraction, right? So ln 4 minus ln x cubed. Okay. What's the last thing we can do here? Exponent, right? We can move that cube to the front, right? So this would turn to ln of 4 minus 3 ln of x. Any questions on example 4? All right. So we are going to move on to a more complicated topic. Same thing, but we have a little bit more going on. Now, this is something that might take a little bit too much time to do on the test or quiz that's timed, but I think there's something very similar to this question on the homework. Okay? So let's go through this one. We have log base a of x cubed squared root of y over mz squared. There's multiplication going on, division going on, and exponents and square roots going on, all in the same question. Okay, let's try to figure out how we would undo this. Okay, what do you think we should work with first? The multiplication, the division, or the exponents? Why do you say multiplication? Oh, okay, so I think you're saying what I'm saying. I just worded it differently. Yeah, totally fine. The biggest thing going on here is the division. I'm gonna take this step by step, okay? So before I even deal with the multiplication, I'm going to undo that big thing up top divided by the big thing on the bottom, okay? So division turns into subtraction. So this turns into log base A of x cubed square root of y minus log base A of mz squared. Everyone's kind of working 2 steps ahead of me, but I'm going to do this step just by itself. So since we have 2 things being subtracted from each other, and there's multiplication going on the inside of the logs, okay, we can work with each of them and split them up into addition. Okay. You might think I'm crazy right now, but I'm going to do something weird. Because there's a subtraction and I'm planning on expanding these subtractions into larger additions, I'm going to put each of these guys in parentheses or brackets. Okay. The reason I'm doing this is I just want to keep things separated and I don't want to mess up the signs of each of these guys at the end. So bear with me. I'm going to put the brackets. We'll see what happens in the future. Okay. So let's work with the first bracket. How can I simplify the first part? Just one step. I think I saw it. Take the inside and split it up into 2 things, right? This would turn into log base A of x cubed plus log base A of the square root of y. All right, you're all with me here, right? We just split that up into 2 additions. Okay. Now we have a subtraction sign, and we're going to work with the right-hand side. Okay, I'm going to keep this in parentheses, and you're going to see why I'm doing this. Okay, the log base A of mz squared, well, I can split that up into log base A of m plus the log base A of z squared. So all I did is expand each of those multiplications. Okay. So what can I do on the left-hand side? How can I simplify this further? Yeah, bring the exponent up here, okay? I'll do an extra step with the square root. What's another way of saying the square root? Y to the 1/2, good. So the left-hand side turns into log base, 3 log base A of x plus 1/2 log base A of y. Does everyone kind of see the step I skipped? I knew that the square root of y is y to the 1/2. I brought the 1/2 in the front. Okay. Working with the right-hand side, we can do the same thing. We can move that 2 up to the front of the log z. So log base A of m plus 2 log base A of z. Phew. Okay. We've done everything where we can simplify everything into a log of like 1 letter. But there is one more thing we can do to simplify this expression. Does anyone see it? Yeah, distribute that negative sign over, right? So the reason I put this guy in parentheses is because I expanded it into 2 different things and we're subtracted. So I kept this parentheses so I can keep that negative attached to each of these. Oh. And we can distribute the negative sign to both the last 2 terms. So this turns into 3 log A of x plus 1/2 log base A of y minus log base A of m minus 2 log base A of z. Any questions on the steps for this question here? Okay. So example 6 is pretty much the same. I think it's a little bit easier since there's no square roots. Try example 6. We'll come back in a bit And be careful about that negative side. All right, let's come back up to the front. All right, Layla wrote up the example 6. Do you kind of want to take us through each of your steps?
Basically the top of the fraction minus the bottom of the fraction. And then I wrote that out, essentially in brackets. And then I took the 3 down from the x cubed term. I kept the second term the same. And then I distributed the negative to the other terms. And then got my final answer by bringing the 2 down in the third term and 5 down.
Awesome. Does anyone have any questions about this example? All right. So last thing we're going to do, okay, I think we're pretty comfortable with taking like one logarithm and expanding it out into a bunch of different ones, right? But we haven't really talked about going the other way, which we can do, okay? So sometimes the question is going to give you like a bunch of added logarithms or a bunch of subtracted logarithms or something with multiplication up on the front, and they're going to ask you to express it in one logarithm, okay? So instead of having a bunch of them going around, we're just going to express it as one big complicated log. So let's take a look at this one. Before, when we did questions where we expanded a logarithm, we would start with the addition. Yes, we start with the addition, subtraction, and then we work with the exponents, right? When we do the other way, oh my gosh, when we do the other direction, we're going to work with the exponents first, and then we're going to do the addition and subtraction. So we're working backwards, okay? Taking a look at part A, what do you think the first thing we should work with first is? Oh my gosh. Oh, sorry, I didn't hear. The 1/2, right? Normally, the 1/2 would be the last thing we do, right? But since we're working backwards, why don't we take the 1/2, which is up front, and bring it to the exponent? So instead of the exponent up front, we're taking things up front to the exponent. So this becomes log base 5 of 7 plus log base 5 of 5y to the 1/2 power. Yeah, right. So instead of converting a square root into a 1/2, when we see a 1/2 power, well, that turns into a square root. Okay, so we can also rewrite it as this. So we work with the exponents. Now we can deal with the adding and subtracting. Okay? So we want to put this as 1 logarithm of base 5. What should go in the middle? Yeah. Awesome, right? Addition on the outside turns into multiplication on the inside. Just like how multiplication on the inside turns into addition on the outside. So we're just working backwards here. Okay, we have 1 logarithm, so we're all good. Any questions on part A? All right, so this would be our final answer. Why don't you guys work on B, C, and D? I think they're a little bit easier than part A. So I'll let you work on these, and we'll come back in a little bit. Let's come back up to the front. Number or part B. That's Sam. Sam, do you want to take us through your steps here?
Yeah, so there's a 4 in front of the log to y. So I moved that to be the exponent of y. And then I saw that you couldn't really do most of the other part. So I just, since it's fraction, I simplified it down to the division.
Awesome. I got a good question. Which one becomes the numerator? The first one becomes the numerator. The thing that's being subtracted becomes the denominator. Good job on that one. Any questions, part B? Okay, part C, was that Amelia? Amelia, you want to talk about how you got this answer?
Yeah, the only thing I was the 3 the first second exponential y,
Awesome job. Any questions on part C? Okay, and part D, I forget who wrote, was that Stephen? Do you kind of want to explain how you got to your answer here?
So I just combine the last number.
Yeah, so it turned into multiplication. Stephen wrote it two different ways, which is really good. Either way is fine for me. Okay, so if you want to put the multiplication sign there, it's fine. Of course, multiplication is the same as just not writing the times side, right? So either way would be fine with me. Any questions on any of these guys here? All right. I think I'm gonna let you guys out early today. Tomorrow, we're gonna start on the angles, which is kind of our, it's leading us into the trigonometry section, but I promise you, it won't be as bad as you think it is.